Okay, so homework 8, question 4. We got two equations. One is y equals x, and then brackets 5 minus x, and then we got 2y equals 5x plus 4. We want to show that these guys do not intercept in any way possible. So the first method you do then is obviously set them equal to each other. Now we can't go straight for it at the moment because we've got 2y there and a y there. So what we do want is them both to equal y. So if we put here y is half of 5x plus 4, and then we can go from there then. So we're going to have x, 5 minus x will equal half 5x plus 4. So what we're going to effectively do is set them equal to each other, and hopefully we're going to get a quadratic of some sort, and then we can use the discriminant then to show that they won't intercept, because if they don't intercept they have no roots whatsoever. So we do all this then, so we're going to have 5x minus x squared here will equal half 5x plus 4. We times everything by 2, we're going to have 10x minus 2x squared equals 5x plus 4. Now what I'm going to do, because we've got a minus 2x squared, I'm going to move everything over to the right hand side. So what we're going to have is 2x squared plus 5x minus 10x plus 4, and that will give us 2x squared minus 5x plus 4, which is equal to 0. So I underline that, that's fine. So what we've got there is we've obtained a quadratic, and now we need to prove that they don't intercept. And if they don't intercept, that means they've got no real roots, and then of course we go on from the discriminant. So if they've got no real roots and they don't intercept, then b squared minus 4ac is going to be less than 0. A is 2, b is minus 5, and c is 4. So what we're going to have here is minus 5 squared minus 4 times 2 times 4. Let's give us 25 minus 8 minus 32. And of course 25 minus 32 will give us minus 7, and of course this is less than 0, so no roots, so they don't intercept. That's your final answer. Okay, so question 4b. We want to draw these two graphs now to show that they don't intersect, so it backs up our algebraic method in part A. What we got here is obviously we got a quadratic. Okay. Now if we multiply this out, x times minus x will give us that minus x squared. So we know instead of our normal positive quadratic that does that, we got a negative quadratic, so it's going to have that kind of shape. What we got here is 2y equals 5x plus 4, so we know that's going to be a linear, that's going to be like a straight line somewhere. Because it's positive 5x, obviously it's going to be a positive gradient, so it'll be somewhere along the lines of that. Now we have a look at this. X and then 5 minus x. We know there, x, if we set y to 0, we know x can intercept at 0. So see, if I write this down actually, because then you see what I'm talking about. For x-axis, set y to 0, so you can have x and then times 5 minus x equals 0, so x equals 0, 5 minus x equals 0, so x equals 5. So again you'll have a intersection there. Okay, so because it's a sketch, I'll just draw this, and we should have something along the lines of that there. Okay, we have a look at this chap here. Again, x-axis. So set y to 0. 5x plus 4 equals 0. So 5x equals minus 4. And of course x will equal minus 405, which is 0.8, which is roughly about there. Okay. So that's where it's going to cross the x-axis. Now we want to find out where it's going to cross the y-axis as well, so we're going to set x as 0. So y, or 2y should I say, 2y will equal 4, so y will equal 2. And then of course you know then that straight line is going to pass through there. And of course use a ruler then, because it's obviously a linear, we're going to have a line like that. Probably not the best draw in the world, but hey. And obviously this shows then it will not intercept. This should obviously be a bit more curved downwards, I'd say, but just ignore this bit. And that's your final answer there.